Jai Hind, my name is Mukulit Goel and I am Assistant Professor in Department of MCA, and today I am going to present a topic on fuzzy logic and its operation from subject data analytics. Subject code is KCA 034 and it is for the MCA second year students. Now let us start. What is fuzzy logic? What is the why we require fuzzy logic? How they are different from crisp set and operations on fuzzy logics or sets. First, what is fuzzy? Fuzzy means ambiguity. What do you mean by ambiguity? Ambiguity means where we don't have anything certain, or we can say that any false information. But in terms of data analytics, what fuzzy means is, what fuzzy can do, is what it can give you a prediction, it can give you a result which is not definite. Which is not definite means if I would like to say, is I am honest? Yeah, somebody asks, is Mukulit honest? So there is not a definite answer of this question. I am 100% honest, or I am a 0% honest. So for these type of questions we use fuzzy. Fuzzy is defined by Lofty Jade. He is known as the father of fuzzy sets, and it uses all the membership or element which we use in sets, classic set theory. Okay. In classic set theory we have only two answers, one is 0 and one is 1 and another is 1. In fuzzy set theory we have the values which mean between the intervals of 0 and 1, including the both sides 0 and 1. Means in fuzzy set, if we denote it by f is equal to, we can write values 0, 0.2, 0.3, 0.7 or 1. But in crisp set S, we have definite values which is 0 or 1. Okay. So it is fuzzy, means what we have defined in fuzzy, the values between 0 and 1. Why we require fuzzy set? We require fuzzy set because our system are unable to answer some questions which are not definite, which are unreliable. Like I have said, I am honest, or somebody asks that Mukulit is honest. So this answer is not definite. It is incomplete. It can give you an incomplete answer. So for these type of questions we use fuzzy logic. Okay. So for these type of questions we want our system to answer these type of questions. So we use fuzzy sets. In these type of questions, fuzzy system provides a solution because they will told ki Mukulit is 50% honest or 90% honest or 10% honest. It cannot simply say ki honest or dishonest. Next, how they are different from crisp set? What is crisp set? Crisp set is simple. We got the answer whether true. We got the answer whether true or false. Like, is AKG a college? I will explain this example later also. Is AKG a college? Yes, AKG is a college. So you can define it in a set. The values of AKG, it has the exact boundaries. Yes, it is a college. Okay, and there is no uncertainty about this answer. We know that AKG is a college. We know that everybody knows that AKG is a college. Okay. In terms of fuzzy set, there is no definite boundaries. Okay. It is defined by the ambiguous boundaries and used in fuzzy controllers. Now the important thing is, what is fuzzy controllers? Fuzzy controllers are like washing machine. Examples are washing machine. Washing machine are the proper examples of fuzzy logic. Let us understand with the example what I have defined. Is AKG is a college? Yes, AKG is a college. But if we want to find the faculties which are working in AKG are dedicated or not, we do not get the definite answer of this. what we will find is some are extremely honest, some are very honest, some are honest at some times, and some are extremely dishonest. So these type of questions or these type of examples can be solved by the fuzzy logic. Understood? Okay. In classic set theory, a set is a well-defined collection of objects. An object is in a set is called an element or a member of that set. Set are defined by a simple statement, which is A belongs to A to A belongs to A values from 1 to n. If the elements of AI is 1 to n of a set are the subset of universal set X, okay, and then they are represented in the form of the elements of set, means set A of X is equal to 1 if X belongs to capital X, otherwise 0. Means if we want to list a college of Delhi state, in that condition AKG will not be the part of this set. But if we want to define like colleges in the Ghaziabad, then Ajay Kumar Engineering College is a part of this set. The operations in classic set theory are union, intersection and complement. In union, we consider both. In AND, we find the intersection of two sets, which is given by X belongs to A and B, means that thing will be in both of the sets, in set all A also and in set B also. And complement means the X does not belong to the set A and is also not belongs to the set universal set X. In fuzzy sets, it is the fuzzy set theory is an extension of classic set theory, in which what we want to do that in some conditions true and false is an insufficient answer. Okay. So in those conditions we use fuzzy logic when we use the whole interval between the 0 and 1 to describe the reasoning. So fuzzy set allows the members to have different degrees of membership, like I have defined F is equal to 0, 0.2, 0.1, 0.001. All these are the degrees of membership which having the interval between 0 and 1. Fuzzy set is defined as the universe of discourse and X is a particular element of X. Then the fuzzy set A is defined on X and can be written as the collection of ordered pair. Means X belongs to X, A belongs to X and X is the part of that universe. Its degree can be anything from 0 to 1. The operations, fuzzy set operations are also being taken from the set theory. Same operations, union, intersection and complement, but there is a difference. In fuzzy set, what we will do in union? We find the maximum values of both the sets. In intersection, we take the minimum values of both the sets, and in complement, we do the negation from 1. Means the value of set A in fuzzy set, if we take a complement, then all the values of fuzzy set A is done by then 1 is minus from all the values. Like first we come for a union. It is the fuzzy set A which has the values x1 is 0.3, x2 is 0.5 and x3 is 0.1, and B is x1 is 0.5, x2 is 0.7 and x3 is 1. So for union, what will we take in? What we have take that from A and B union, the value of x1 is 0.5. Why? Because when we compare 0.3 with 0.5, so the 0.5 is larger. Okay. In x2, when we compare 0.5 and 0.7, then 0.7 is larger. So we take the value of x2 which is 0.7. And in terms of x3, when we compare 0.1 with 1, we take the value 1. Why? Because in fuzzy set, the union means the maximum value for that set. So the maximum of set A of x1 and from the set B, So 0.3 and 0.5 we have taken 0.5. For x2 we taken 0.7 and for x3 we have taken 1. When we come in terms of intersection, what we have taken in intersection is x1 is 0.3 in set A, x2 is 0.5 and x3 is 0.4. For set B, x1 is 0.5, x2 is 0.7 and x3 is 0.1. So the intersection, in intersection we take the minimum values. So we find the minimum values from both the sets. For x1, in the set A, x1 is 0.3 in set A and 0.5 in set B. So what we have taken? We have taken 0.3. Okay, it is minimum. For set 2, 0.5 and 0.7 we have taken 0.5, and for x3 0.1 and 0.4 we have taken 0.1. For complement, what we will do, we will negate it by 1. So the values are 0.5, 0.7 and 0.0. When we negated them by 1, so value of x1 is 0.5, x2 is 0.3 and x3 is 1. So 1 minus 0 is equal to 1. So 1 minus 0.5 is 0.5 for x1. For x2 is 1 minus 0.7 is 0.3, and for x3 1 minus 0 is equal to 1. Now let us understand with a simple example in which what we will do, we will recognize the single English alphabet from A to H in an image processing system. Each A to H have their own values, and what we want to do is find the law of associativity, which is A union B union C is equal to A union B union C. So compare each values of x, y, z. Instead of A, make it x, y. So it is x union y union z is equal to x union y union z. So what are the values of A, x? Values of x for A is 0.2, for B it is 0.4, for C it is 0.9 and for D it's 0.1. For C it's 0.9, for D for D it is 0.1, for E, F, G, H. For E is 0.8, 0.5, 0.3, 0.2. 0.8, 0.8, 0.5, 0.5, 0.3 and 0.2. Say in the same way, we will take the values of y, A, B, C, F, G, H. A is 0.6, 0.2, 0.9, 0.6, 0.2, 0.9, 0.6, 0.2, 0.9, 0.5, 0.6, 0.3, 0.6, 0.3, 0.1, 0.5. Now third comes Z. 0.4, 0.7, 0.2, 0.9, F 0.7, G, H 0.4, 0.6, 0.4, 0.6. Now what we are trying to find, X union Y union Z is equal to X union Y union Z की values. Is it the same or not? So for Y union Z, what we have taken, what is the value of A is 0.6 because 0.6 is higher. For B, what should be the value? 0.7. For C, it's 0.9. For D, it's 0.5. For E, it's 0.9. For F, 0.7. For G, 0.4. And for H, 0.6. So it comes Y union Z. When we talk about now, then we have to union it with Y union Z, the value of X. So A will become 0.6, B will become 0.7, C will become 0.9, D will become 0.5, E will become 0.9, F will become 0.7, G will become 0.4 and H will become 0.6. So the value of X union Y union Z is equal to 0.6, 0.7, 0.9, 0.5, 0.9, 0.7, 0.4 and 0.H for each alphabet which from A to H. Next, what we have to find is X union. Now first erase it. Now X union Y is equal to, for A, 0.6, for B, 0.4, for C, 0.9, for D, 0.5, for E, 0.8, for F, 0.5, for G, 0.3 and for H it will be 0.5. When we do it again union with Z, what we will find, X union Y union Z is equal to, value of A will be 0.6, value of V will be is equal to 0.4 and 0.7 is equal to 0.7. Value of C 0.9 and 0.9 is greater. For D 0.5 and 0.3, 0.5 is greater. For E 0.8 and 0.9, 0.9 is greater. For F 0.7 and for F 0.5 and 0.7, so 0.7 is maximum. For G 0.4 and 0.1, 0.4 is maximum, and for H 0.6 and 0.6, so it will be 0.6. So you can see कि X union Y is equal to Z, X union Y is equal to Z is equal to X union Y union Z. So we have proved that the law of associativity using fuzzy logic. The same can be done in the terms of intersection by taking the minimum values from each set. It's X in it's X intersection. Oh. So now we take the minimum values for Y intersection Z is equal to minimum values. A will be 0.4, B will be B will be 0.2, C will be 0.2, D will be 0.3, E will be 0.6, F will be 0.3, G will be 0.1, and H will be 0.5. So we have taken the minimum values of each element of the set. In 0.6 and 0.4, 0.4 is minimum. In 0.2 and 0.7, 0.2 is minimum. For C, 0.2 is minimum. For D, 0.3 is minimum. For E, 0.6 is minimum. For F, 0.3. For G, 0.1 and H is 0.5. Now we will do it intersection with X. When we do it intersection with X, 0.4 and 0.2, it's 0.2. 0.2 and 0.4, it's 0.2. For 0.2 and 0.9, 0.2. For 0.3 and 0.1 is 0.1. For 0.6 and 0.8, it's 0.6. For 0.3 and 0.5 is 0.3. For 0.1 and 0.3 is 0.1. And for H, 0.5 and 0.2 is 0.2. Now we will find the value of X intersection Y. X intersection Y for A. 0.2 for B, 0.2 for C, it is 0.9 for D, it is 0.1 for E, it is 0.6 for F, it is 0.3 for G, it is 0.1, and for H and for H it will be 0.2. In the same way, we will find the value of intersection with Z. Then what we will find कि 0.2 and 0.4 is 0.2, 0.2 and 0.7 is 0.2, 0.2 and 0.2 is 0.2, 0.1 and 0.3 is 0.1, 0.6 and 0.9 is 0.6. For F, it will be 0.3 and 0.7 is 0.3. For G, it will be 0.1 and 0.4, 0.1. For H, 0.2 and 0.6, it will be 0.2. So we find that the value of, again we proved the law of associativity using fuzzy set. In this way, we will do the operations on fuzzy sets of operations of union, intersection and complement. Thanks.